By 2026, the promise of enterprise AI is total autonomy, fully independent agents that can replace human support teams and instantly execute workflows. But that sleek vision hits a wall of legacy infrastructure. Most businesses run on mainframes and decades-old SQL databases, environments that were never designed for a high-speed, automated worker to navigate. Directly connecting a probabilistic model to these brittle layers without a robust middleware layer creates security vulnerabilities that simple firewalls were never built to patch. If an AI hallucinates a database query or an API call, it isn't just a bad chatbot response. It's an unauthorized financial transaction written into your permanent records. Organizations are now caught between the pressure to automate and the liability of a system that can make mistakes at machine speed. The market is currently correcting itself, shifting from passive conversational systems towards active, tool-using architectures that possess memory and agency. This correction is driven by a shift in goals, moving from deflection to resolution. For years, chatbots were defined as stateless, reactive interfaces. They retrieve a polite, pre-scripted answer from a knowledge base, and the interaction ends with a human still needing to take action. This matrix shows why deflection alone is failing. Chatbots are stateless and reactive. Their logic is limited to text generation and guided flows. On the right, true agents operate as reasoning engines. They maintain state across a conversation, select the right tools for a job, and proactively execute plans across your internal systems. This autonomy makes agents non-human identities, software entities that can update records and move money. While chatbots handle low-risk FAQs, an agent with too much power can compound a single reasoning error into an external liability. Without distinguishing between these two paradigms, organizations risk investing in expensive toys that generate more support tickets than they resolve. Transitioning to a resolution-first model requires solving the problem of fragmented business context. In most stacks, HubSpot knows the deal stage, Gmail holds the buyer conversation, and Slack contains the team context. No single app sees the full truth. An agent requires a unified interface, a centralized control room where all these signals converge into one operating surface. Within this workspace, the agent reads the CRM, inspects the email history, and drafts a next step that reflects the entire deal context. Centralizing this data is the mandatory requirement for an agent to make useful, autonomous decisions. To safely govern that centralized data, teams are adopting a free-tiered orchestration flow. It starts with the first tier, pre-execution oversight. This tier creates a mandatory human check before the agent takes any irreversible action. For instance, an agent might detect a stale deal and draft a Gmail follow-up, but the system won't send it until the account owner clicks Approve inside a Slack alert. This guarantees brand safety, though it introduces workflow latency. The agent can only move as fast as a human can review the work. Even with that delay, pre-execution is the safest starting point for deployment. It treats human oversight as a deliberate architectural layer, rather than a failure of the automation. The second tier is in-execution oversight. Here, the agent dynamically interrupts a human mid-task based on confidence and monetary thresholds. Because model-reported confidence can be miscalibrated, systems rely on external verifiers. If reasoning is ambiguous, it escalates the task to a supervisor. The final tier is post-execution audit. This is a periodic review of completed logs to ensure the system hasn't drifted from policy. Audit trails are now a legal requirement. Under the EU AI Act, organizations must document exactly how high-risk outputs are reviewed before impacting consumers. These controls increase cloud costs and require time from senior staff, proving that high-level autonomous AI is never truly unsupervised. Choosing the right path requires evaluating your specific risk profile to avoid a one-size-fits-all mistake. This quadrant chart maps workflow complexity against risk tolerance to help define your deployment blueprint. In the bottom left, low risk and low complexity, basic chatbots remain the most efficient choice for deflection and triage. They offer fast deployment for SMEs, but hit a wall when tasks require cross-system execution.
In the bottom right, high complexity, low risk are single agents designed for internal operations like CRM hygiene. These agents typically reduce the manual overhead for tasks like data entry or invoice reconciliation by 40 to 60%. They accelerate internal time to value without risking external client relationships. Finally, the top right quadrant, high risk and high complexity, is the domain of multi-agent systems bound by strict human-in-the-loop governance. For a logistics client, this architecture reduced resolution times for shipping disputes from 48 hours down to under 5 minutes. The system automatically queried carrier APIs, verified SLAs, and calculated penalties. However, building here requires heavy upfront costs for API gateways, message queues, and rigid compliance architectures. Only well-funded organizations where replacing Tier 2 human intervention justifies the engineering expense should attempt to build in this quadrant. In 2026, the decision is no longer about which bot to buy, but whether to prioritize cheap deflection or to invest in the technical toll required for autonomous multi-system resolution.